Hello, dear student. How are you? I hope you all will be fine. I'm also fine. Thank you. Welcome to your channel. That is Asia Science Group. Let's start today topic. Today is Fry rearrangement. That is one scientist called name whose name is Fry, whose name is that was German scientist whose name is called Theophile Freyser. So that's why from his name he proposed some mechanism for some reaction. So that's why this reaction or this rearrangement is called Fry rearrangement. According to Fry rearrangement, this Fry rearrangement named for the German chemist called Theophile Freyser. It is a rearrangement reduction of phenolic ester to hydroxyaryl ketone. That is one phenolic ester. That is phenolic ester. That is phenol that is bonded with O, and O is bonded with the C double bond OR. That is phenolic ester. So from this phenolic ester, it will be rearranged and produced. It will be rearranged and produced orthohydroxyaryl ketone, or it may can be produced a parahydroxyaryl ketone, but never can make it produce metahydroxyaryl ketone. Why they cannot produce metahydroxyaryl ketone? Because in meta position here in this case in OH group, OH is electron donating group towards this. So that's why electron, when they are electron donating groups, the positive charge, or you can say that the negative charge on ortho position or para position, it will be more, while the positive charge on meta position will be more. The negative charge on ortho and para will be greater, while the positive charge on meta position will be greater. So that's why carbon cannot be attacked on meta position, because of carbon itself are electropositive. Here is itself they have partial positive charge, because it is connected with, it is bonded with the most electronegative element, that is oxygen. So oxygen will draw the electron. That's why carbon will get partial positive charge. So that's why positive charge cannot attack on this sites. So we will be discuss it in later in mechanism. Let's proceed the topic. Lewis acid will be used as a catalyst. Lewis acid mean that can be act as a electron deficient compound, that have some electron deficiency, that have some vacant orbital, like AlCl3, that is electron deficient compound, like BF3, that is electron deficient compound. So we will use Lewis acid as a electron as a catalyst. It involves migration of an acyl group of phenol ester to the aryl ring. It produces, that is acyl group, C double bond OR, that is called acyl group. That will be transformation of this group, will be migration of this group will be occur from this ester, from the phenolic ester to the aryl ring, to this ring. That is one aryl ring or aromatic ring, you can say that is aromatic ring. So that's why this bond, this group will be, this is called acyl group. This acyl group from this C to OR, this acyl group will be shifted, this will be migrate from this position toward, or it will be either to this aryl ring of this position, or the position of aryl ring of this. So that is either it will be produced ortho, this acyl group either will shift on the ortho position, or either it will shift on the para position, but never in meta position. I hope this point will be clear. Let's do the mechanism. Mechanism of this reaction is that is one phenyl ester, that is phenyl, that is the same compound as I write in the previous page. So that is phenyl, and that is bonded with this acyl group. So this is this oxygen is bonded with the C, and this oxygen is like double bond O and CH3. This CH3 is bonded with this carbon, and O will be double bond to this carbon. So that's why there is phenyl ester, and the presence of AlCl3. What will be AlCl3 do? AlCl3, it is electron deficient compound. It can withdraw the electron, or it can accept the electron or lone pair, because it have one vacant orbital. So that's why it can accept electron pair. So that's why from this oxygen has two lone pair of electrons. So that's why one lone pair will be donated to this aluminium. So that's why aluminium will get negative charge, because it accept electron, while oxygen will get positive charge, because it lose the electron. So that's why oxygen will get positive charge, and it is bonded with the AlCl3. AlCl3 has negative charge, because of aluminium is already neutral, and it accept the electron pair. So but here in the second step, so this compound is produced. This is unstable compound, or you can say that that is one intermediate, maybe that is one intermediate, because anion and cation are produced, cation and anion are produced, that is cation and this is anion. So this is so that's why to produce stable compounds this methoxy group you can sorry this acyl groups this bond will be shift toward this oxygen, or this bond will be shift toward this here double bond produced between this carbon and oxygen. So that's why carbon have complete their covalence. So that's why one bond between this carbon will be broken, because this carbon have already completed their covalence. So that's why this bond will be broke toward here, and here it will be produce negative charge, and this here double bond producer like that double bond, and the positive charge will be remain on this oxygen same, because of oxygen in before oxygen has 3 bonded, here is also oxygen 3 bonds, so that's why positive charge will be remain constant, but here is it will be negative charge. So when this produce CH3OC, that is acyl group, when this acyl groups when this acyl groups become separated, now this negative charge on this carbon that can be resonance stabilizer. By resonating stabilizer, this can attack on this carbon, it will be produced double bond here, and this bond will be shift here, and here it will be negative charge produced. After that you can write that this negative charge attack here, and it will produce double bond here, and this double bond will be shift here, and here negative charge will be produced, and a resonating stabilizer, various resonating structure will be produced. So that's why either this negative charge will be display over ortho position or para position, but never it will be display on the meta position. So that's why this the CH3OC that you can also call it is that acyl group. So this acyl group has positive charge, or this has carbocation. So this carbocation when they have positive charge, so and the meta position of this ring has also positive charge. So that's why this positive charge cannot attack on this positive charge of the meta ring on the ring at meta position. So that's why that will be only attack on the negative charge, that is either at meta position or at para position. But the reaction with on meta position it will be more as compared to its para position, because at meta position the charge density, negative charge density will be more, because here it is near to the to the oxygen or to the electron donating groups. So this positive charge will be this acyl group will be this negative charge will be attack on the this acyl groups, and it will be produced double bond here, it will be produced bonded, so it will be produced same bonds. But this is one acid catalyzed reaction. This is a whole, this reaction is acid catalyzed reaction. This reaction will be catalyzed by an acid, in the presence of water aqueous acid HCl, in the presence of water, or in the presence of HCl, in the presence of aqueous water HCl, aqueous water, this water will be produced take on this hydrogen, and it will be this bond between hydrogen and carbon, it will be shift toward this carbon, and it will produce double bond. But here this carbon have already completed their covalence, so that's why one bond between this carbon and oxygen will be broke, so that's why it will be break towards this oxygen, and oxygen will be get neutral, while this hydrogen will be removed as a proton. Means this step is also called deprotonation, because proton will be loser. So H3O will be produced, and here is Cl2AAL. Here in this case I skip one point, that is AlCl3, that is negative charge, that is unstable. To produce this stabilizer, one Cl will be loser, so there one Cl loser, that's why that will be get neutral. So here is so that's why I write AlCl2, that is AlCl2, that is bonded with the oxygen. Here is H3O plus. This step once again protonation will be occur, but now this lone pair of this oxygen will be attack on this proton, it will be accept a proton from the hydronium ion. So when they accept a proton from the hydronium ion in the presence of HCl or in the presence of H3O, what will happen here? It will happen that here is because this lone pair will be attack on the hydrogen in a hydronium ion, so that's why oxygen will get positive charge, and hydrogen, or you can say that proton have itself positive charge, so that's why proton will be neutral while oxygen will be get positive charge, because oxygen lose electron pair. So that's why here will be OHAlCl2, this compound will be produced as a whole. This compound, everything is remains same as before here, but only hydrogen is added. So to produce stable compounds, that Cl negative, when they are in the first step, so when are in the second step Cl loses, this Cl will be attack once again on the aluminum, and that's why the bond between aluminum and hydroxyl or oxygen, it will be break toward oxygen, and oxygen will become neutral, because electron pair move toward oxygen, and oxygen will become neutral, while aluminum will become positive charge. But here this chlorine is negative charge, so this positive and negative will be cancelled to each other, and it will produce neutral compound AlCl3. This is called orthohydroxy acyl phenol, orthohydroxy at ortho position it is hydroxy, ortho hydroxy acyl phenone. Acyl, it is more bulky, so that's why the main group or the main substituent will be that, but oxygen will be act as a substituent, that will be main group. So acyl phenyl, you can say that that ortho hydroxy acyl phenyl. So this is the whole mechanism. I hope this will be clear. Still, if you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in the description box. You can get from there. Okay, thank you very much. Very best of luck, man. Very best of luck. Also, please subscribe my channel. It makes me feel happy. That makes me are supporting me. Okay, thank you very much. Very best of luck.